All right, kiddos, remember you've got an assignment due April 5th. I'll have details about the assignment for the material we've been covering pretty soon. Today, we're going to be doing like normal. I want you to download a new spreadsheet that's on Banner, and we'll be doing worksheets. I've handed out the worksheets. So go ahead and download the spreadsheet. We're finishing our discussion of using optimization for master production planning. And so after this, we'll start using those tools for transportation logistics. See if you can get the film off that. Men don't have fingernails, so. And what we're doing today is kind of like what we did, I think, last Thursday, where I'm going to start us off remembering what the model is, and then I've given you a spreadsheet to start you with, but then I'm going to have you construct it. And what you're going to have to do for the big assignment for this is you're going to have to construct a similar model, adding in some features. Okay. So everybody has the worksheet that says March 30th at the top. Okay. So this is the same model that we were dealing with last time. Same model we began with, we're just building more to it. We have two different types of gums, and we're trying to figure out the optimal amount to produce each month, the optimal amount to store each month. We have a capacity constraint. Our factory can only produce so much of the gum. And we also have this fixed cost for gum 1, where wherever we produce gum 1 in any month, we have to pay this fixed cost. And what we did last class is we looked at how we made this other indicator variable, Y1I, to make sure that whenever we do produce gum 1, we're charged that fixed cost. We just looked at it conceptually. We just looked at the equation for that, and now we're actually going to implement it, but we're going to review that equation again. And so what I've got here is for number 1 through 4, these are some things. It's like I'm giving you possible answers, and you have to, but there's errors in them, and you have to identify what's wrong with them. Testing, testing, testing. Okay. So number 1, we've got a potential objective function there, and we want to go through it and see where the errors are. And let's just take it one little step at a time. So we have this max thing, and let me see if I need to write it out. No, that shows. Okay, so this is the max thing saying we're maximizing a function. Is that all right? What is our objective in choosing how much gum to produce each month? Minimize cost. So we're not maximizing anything, we're minimizing. That max should say minimum, M-I-N. And then underneath min, that should say what we're choosing to minimize. And so that should only have our decision variables. It should not have any parameters. So everything under there should be only variables that we choose and all the variables we choose. And we have X1I, X2I, so the amount of gum we produce each month. I1I, I2I, the amount we store in inventory each month, and Y1I. Is that all our decision variables? Gianna, give me a yes or no, even if you have to guess. Yes. It is. I don't see anything else. And what is Y1I again? It's a binary variable that equals 1 when... Let me have an answer from someone named Justin. We got 2 in here. Y1I equals 1 instead of 0 whenever... Just make up a wrong answer if you have to. Poke them, Rachel. Tell them the right answer. Give the board some help. 14. 14 is not close at all. What's that line? You ever seen that Happy Gilmore? No, Billy Madison. Quit it. Here's my response to you, Rachel.
What you just said is one of the most insanely idiotic things I've ever heard. At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to that. I award you no points, and may God have mercy on yourself.
As a professor, you're not supposed to discourage participation, but Y1I equals 1 whenever X1I is greater than 0. It becomes 1 whenever we produce something for that month to make sure we're charged a fixed cost. Okay, and then this thing right here is what we're trying to minimize. That's the equation, and it's got a summation. And it's starting I equals 1 to 3. Is everything cool there? Even Steven? Think so? I think even Steven's wrong. When I is 1, that means what? What month are we talking about? March. And I equals 2 is what? What? Yep, you got it. And I equals 3 is what? You're getting it? May. And are those the only months we're dealing with? Nope, we're also dealing with June and July, so that's supposed to say 5 at the top. We're summing over 5 months. All right. And then within this parenthesis is the cost for each month, for the ith month. And we have C1I times X1I, which that should be the variable per unit cost of production. Does that seem okay? William, you think so? I think so too. What about H1I, I1I? Does that seem okay? Yes. Good, good. Yeah, that looks okay. F1I times X1I. F1I is the fixed cost. Does that seem okay? What do you think, Allison? I'm sorry? Say yes or no. You're just saying yes, so you don't have to say why the no, right? Yeah. No, it's wrong. F1I times X1I would be charging the fixed cost for each unit of gum you produce. Well, we only want the fixed cost to be charged once whenever X1I is greater than 0. So X1I should be replaced with what? Gavin. There you go. He said it with authority too. And what about the rest of that equation? Lindsay Ashton Schersch, do you think the rest of that equation looks good? Yes, sir? Is that what you meant? Yep, I think so. So those are the only errors I see there. Okay. This is a teaching method called learning by ridicule.
It's 2021.
Okay. Inventory demand constraint. There's something wrong there. We have to fix it. Now, I'll give you a start here because whenever I have to do this constraint, I've done it for you probably 10 times already, I always have to start from somewhere different with what I know like ending inventories are. And I know that ending inventories, so like I to I, the amount of inventories that we end the month with, amount of gum 2 inventories we end the month with is going to equal however much you start with, ending inventories from the previous month, plus however much you produce that month, minus however much you sell that month. And so, but again, we know we have to rearrange that equation so that demand is on the right-hand side because we know that's going to enter our spreadsheet. So look at that demand right there. And what's wrong with that? Sam, I'm going to call on you on this one. How about that? What's that? Yep, it should say D2 because this is the demand constraint for the second good. I guess you could have also changed the left-hand side to be for good 1, but we'll do it like that. And then there's one other thing wrong here. To see it, you just solve for you want plain D2I alone on one side of the equation. Young Kwan, do you know? June Kwan, I'm sorry. Yeah, should be a plus here and a minus right there. Then we have this production constraint that says there's a maximum amount of X1 and X2 we can produce, and it can't exceed that limit. And so this is the amount in any one month. This is the amount of X1 we're producing. This is the amount of X2 we're producing. That's the maximum amount we can produce, CPI of anything. Anything wrong with that? C. Costello? What's that? And what's wrong with it? Okay, look at what this equation is saying. Remember, this is a constraint. This is saying what has to happen. This is saying amount of gum 1 produced plus the amount of gum 2 produced equals the maximum production level. Yeah, exactly. You should never say we have to produce the maximum amount. The total amount you produce should be less than or equal to that maximum constraint. And then we have this final constraint, and this is the one we left off last time. And this is the one where we need to have the model say y1i is 0 whenever we don't produce any gum1, but y1i is 1 whenever we do produce some of gum1. Because remember, that look back at that objective function, it's going fixed costs times y1i. So whenever we produce gum1 in that month, that y1i needs to go from 0 to 1 to make sure it's reflecting that fixed cost. And there was this isn't a constraint, but it's close to it. We said that this constraint worked. I'm going to just give you the right constraint here. We said that where m is just a really big number. And if you need to know how big it is, just go to look at like the take the total demand of any good, of all the gums of all the periods, and m just needs to be bigger than that. But what this constraint is going to do is that whenever we don't produce any gum in month I, we know this x1 is going to equal 0. So this equals 0. And then we know that if we're not producing any gum1 in any month, Excel's not going to want y1 to equal 1 because then it'll be charged a fixed cost. So Excel is thinking, how do I minimize cost? I want y1 to equal 0 when I can. So if x1 equals 0, it can set y1 equal to 0. This thing equals 0. It satisfies this constraint, and we're not charged that fixed cost. But then to meet some of the other constraints, we have to produce gum1 sometime. There's lots of other constraints as well. So sometimes x1 is going to have to be positive. And if x1 is ever positive and y1 was 0, this left-hand side would be positive, which is not less than or equal to 0, and that constraint would not be satisfied. So if x1 is ever positive, Excel is going to have to also make y1 positive, which multiplied by big number gives us this big negative number over here, which ensures it's less than 0. So it's just a creative way to make sure we're actually paying the fixed cost whenever we produce any of x1i. All right, and then next is to struggle on your own with help. And do work on this, because what I'm going to do for the big assignment for this material, and I think it's going to be like worth 1,000 points. And it's not going to be easy. You'll struggle with it a while, but if you've been working at this, you can do it. I'm going to give you a problem like this. So you're going to start with the same thing we've had so far, but then I'm adding kind of like 2 more elements to it. Things we've talked about. One we actually did in class, and then another one we just briefly talked about, but ones that I think if you understand this model, willing to work at it, you could easily build it. So you are going to have to start with a model and build things yourself. So you want to make sure you can do it, the simple model, in here. Because this is going to be a thing. When you have it, I'm not going to get out clarify questions about what I want you to do, but I'm not actually going to help you build the model. You'll turn it in, then if there are problems with it, then I'll come to you and we'll start thinking about partial credit. But you need to be able to build this stuff on your own. So what I'm doing here for starting for number 5, I'm giving you a bunch of parameter values, what the costs are, what the holding costs are, what demands are, the fixed cost for good 1, and the factory capacity. And I'm starting you off with a sheet where it's partially built, but not completely built, and you need to build it. So go ahead and get started. Let me know when you need help. One question that's coming up is what to do at that block that has to do with the fixed costs and the decision variables. So y'all are used to dealing with these part here, and you knew that underneath, like so you knew that these were going to be your decision variables of how much to produce each month, and underneath it you needed to put the per unit cost. So there you were putting like your 5, 10, 15, 17, 5, and so. But then over here, this is new for you. And so these are your Y1Is. So this is like the Y1I. And so if you produce in March, Excel's going to have to change that 0 to a 1. And if it goes from 0 to 1, you need to be charged that fixed cost. So underneath that 1, or that Y1I for March, you need to have that fixed cost of 1,000. Again, so that right now, it's not producing anything in March, so it's not being charged a fixed cost. But if Excel decides to change that from a 0 to a 1, the sum product is then going to add 1 times 1,000. And I also noticed that, you know, right now you haven't seen any way, like how do you make sure it does 0 and 1s? The way you add that constraint is in your solver. You can add a constraint where you say all of those Y1Is are binary. You just choose binary, and then Excel will make sure that those values can either be 0 or 1 or nothing else. We've got one goal today, and that's to finish that model and complete these worksheets. And then on Tuesday, I'll have the big assignment for this, and it's going to be very similar to this. So what's going to happen is on the big assignment, you've got to build a model that's very much like this from scratch. And you do have to do it from scratch. I've got an Excel spreadsheet where you basically can't copy and paste something from another worksheet in there. You've got to build it from scratch, very similar to this, except I'm adding a few additional constraints. I think they're pretty easy. And so what I'm going to do, a lot of you got the model completely built yesterday. Most of you got somewhat close. Ethan, you were a little behind because you were trying to guess the answers instead of having the computer did it, but we learned that's not a good way, right? Yeah, I mean, you may be able to pick stocks, but you can't just go with your gut. Okay, all right. And Gianna took a break to post some dank memes during class last time, but she still had plenty of time to catch up, and I think she got it, you got it finished, didn't you? Yeah. And Kylie's looking for a new outfit online. It probably won't take long. I thought what she was looking at was both very attractive and reasonably priced, so I think she'll be able to get that purchase soon out the way where we can and have plenty of time to finish. All right? Okay. You got somewhere fancy you going?
Graduation dress.
Oh, okay.
Yeah.
Well, someone's mighty sure of themselves about this class, aren't they? Okay. Okay, so I'm going to start building, and I am going to refer to some of the formulas a little bit because you've seen enough of this sum product formula and you've seen these equations enough that I think you may, after today, you may be able to start understanding how those equations works, because on the exam you are going to have to make those abstract equations like I've been doing up here, and you're going to have to do it in Microsoft Equation Editor. So we were starting from this, and on your, and I'm just going to call it the exam. It's going to be worth 1,000 points, what I think will be the assignment of the most points given in here. It'll be completely blank. There'll be a thing that you'll have to click at the top before you start the exam on it, because then the spreadsheet's going to record everything you do, and it'll record whether you copied something from another spreadsheet or another document here. You're going to have to make these things, the decision variables and things like that, but I don't think you'll have any trouble with that. And so you'll have this decision, we have our decision variables here, and we have the per unit cost underneath it. And I think by now you found that that sum product formula is actually very convenient. And so we put all our decision variables on one row, and we give them a name like I think most of us named it, DECVAR. And then we said that when we wrote our objective function in the abstract, it looked something like this. We said we wanted to minimize by choosing, we put our decision variables underneath it. You're going to have to do this on the exam in Equation Editor. It's going to take you a little bit to learn. I think those were all our decision variables. How much we produce, how much in inventory, whether we produce gum 1 in any particular month. And then we said what we're trying to minimize was we summed over all 5 months. And then here we had X1I times C1I plus H1I times I1I plus F1I times Y1I plus X2I C2I plus H2I. We had that big equation there. And notice there's a sum. We're summing over 5 months. And in each of those things, you're summing products. So this is a product. Per unit cost times the amount we produce. Another product. Whether we produce or not times the fixed cost. Another product. How much we stored inventory times the storage cost. So there's a bunch of different products, and we're summing them up. And that's why we arrange our spreadsheet like this, such that everything that we're going to multiply by each other is stacked on top of each other. We're going to multiply this times this, plus this times this, plus this times that. And so this whole thing, this times that, is that big sum product formula. Helps us keep organized and makes it clear what we're doing, and it makes it easier to debug the program when we find problems. For our demand and inventory constraints, took a little work, but I think we all got there. We were able to do that. And I'm just going to show you one more thing. Well, no, I think y'all all got that. So we're going to, there is going to be, on the exam, you're going to have to do one thing a little different with the inventory constraint. You're going to have to allow for perishability. You're going to have to allow for shrinkage. There was a lecture, there was a worksheet where we actually did this. So we've done this before. You'll have to go back and find the worksheet where we did it, go back to the lecture where we modified the spreadsheet for it, and you can see exactly how to do it. And we're setting them up so that every, let me change this. Well, we set this up such that every time we have a constraint, we use that same sum product formula, which is why it was so convenient to name our decision variables. And it's summing, it's another sum product formula there. We have a left-hand side and we put a right-hand side. And this was a case of equality constraints. And that constraint, we were trying to reflect the formula where we said that x1i minus i1i plus and do know on the exam that beginning inventory for the first month of March will be 0. The structure is going to be exactly like this. It's going to be 5 months, March, April, May, June. It's going to be 2 gums. So it's not like a really different thing you'll be dealing with. And so we want our equation to reflect this. And remember, this is another sum product thing. So it's like we know in the spreadsheet somewhere there's going to be an x1i, somewhere there's going to be an i1i, somewhere there's going to be an i1i minus 1, and somewhere there's going to, on the right hand side of our equation, there'll be a d1i. And so we want to make sure that sum product formula reflects this. So we know that it's like this is multiplied by 1. So we know we're going to want a 1 under there. We're going to want a minus 1 under here. And we're going to want a 1 under there. So it's like when you're setting up those constraints in that sum product formula, whatever constant is being multiplied by that decision variable, you just want to put that underneath it. And so we know when we do that constraint, we're going to want a 1 under here. There'll be a bunch of things. There'll be a negative 1 under here. There'll be a bunch of things. A 1 under here. There'll be a bunch of things. And yeah, so let's take April. For our inventory constraint for April, there was a 1 under production for April. There was a 1 under x1i. There was a negative 1 under inventory for then, so negative 1 under I1i, and there was a 1 under last year's ending inventory, so a 1 under I1, I minus 1. And so again, We're just setting up a sum product formula. Where it's this times this plus this times this plus this times this. And we got to know how to be able to program it in that matrix language, and we've got to know how we write it in abstract form. And so again, this is like a sum product here. 1 times that plus minus 1 times that plus 1 times that must equal that. And always remember, parameters, things that I give you that are numbers that don't change, always on the right-hand side. Anything that's a decision variable, things that Excel is choosing, that's always on the left-hand side. And then for our inventory for constraint as X2 is very similar, except that we have this whole block of 1s and negative 1s that go under the X1 stuff. And so I can just take all of those and copy it and paste it under the X2 stuff. Does anyone know why this isn't showing? My Mac never does this. Have y'all ever had this happen? There we go. All right, I'm about to restart it unless someone has some suggestions. I'm like an idiot up here. Well, let's do this instead. So I don't have to, because most of you got close anyway. What was the right answer? 28,300? 20,800? Okay, did anyone not, I know some of you, so some of you need to be raised up. Did any of you not get 20,800? Okay. Y'all did? China, Yukon, did y'all get it? Ethan? Gianna? Okay, we'll come to you in a, oh, but Stephen, you had it right? Okay, we'll come to you in a second. I'll come to you in a second, Gavin. So let's, so we're doing that worksheet, the number 2. This is where we fill it in. And you said 20,800. And Ethan, what was X1 for March?
Me?
Yeah.
600.
And then April?
400.
Next?
0, 200, 300.
X2?
300, 500, 100,
100, 100.
all 100.
Okay. I1I?
300, 400, 100, 0, 0.
And then last one?
All zeros.
Is that what everybody else got? Okay. And so the next thing, did you do the fixed production costs and all that stuff too?
Yeah.
Okay, so what was your fixed production cost?
4,000.
Variable production cost?
15,200.
And inventory? 60?
1,600.
1,600. Yeah. And when you make this on a test, you always want to make sure these 3 costs right here do sum up to your total cost. Okay. Okay, so those of you who got that answer, what you're going to do next, you're going to go into your model and you're going to change it such that now the production constraint is relaxed. Maybe we get more factory space, and now we can produce up to 10,000 units of gum in any month, and then resolve and recalculate the new optimal values. And Sarah and I will come around and help anybody who didn't get that answer for number 5. So if you got this answer for number 5, go ahead and do number 6.
We weren't really sure what it was on Tuesday.
Yeah. Yeah, I remember looking at it. Hey, hey Courtney, yeah. Can you bring up your solver dialog box real quick and turn it around so we can see it and compare? Does that look the same to you?
So far. looks the same.
Okay. So this is something in the setup. And it's finding a solution. Okay.
Are you good?
Yeah, thank you. See, even though that's wrong, you had it right in the thing. Like in the solver dialog box, that was right. You download a,
Go to Best Buy.
two, 3, 1,000, 2. I can't. Let me get Sarah. Hey, Sarah. Can you look at this sheet, see if you can find, I can't see an error. He's not getting the right answer, but I can't find an error at all. And one way sometimes like I'll do is I'll plug in the right answer and it may show a constraint's not satisfied, and that helps you get the right answer. Figure out, debug it.
Okay.
So is this on the number 6 part? Did you get the 5th part right?
No, he's still number 5. Everything looks right to me, but he's not getting the same answer.
Because that's the answer that I just got on the next part.
Oh.
On the next page. Whenever it changed to 10,000, so it might be something with the like total production constraint.
Well, this is the factory constraint. Let's see. But that's the exact same answer you got?
Yeah, I got 16.4. I don't know if all the others are the same.
Let's look at the.
Yeah, and then I got 2. Yeah, actually, yes.
See, this should be that constraint. No. Let me actually Your computer's annoying, Gavin. Oh my God. Oh, let's see what happens when it could be fun if it gives us the right answer for the other problem.
Yeah. That's so strange.
Okay, so something's wrong in that production constraint. It's not binding at all when we do it right. So this should be 900, right?
Mm-hmm.
Did you maybe have 9,000?
Yeah, it was 900 earlier.
Yeah. Oh, well, yeah, it should be highlighting right there.
Yeah. What is it?
But it's choosing up there. You see what I'm talking about?
Mm-hmm.
Yeah. So it should be selecting along there.
So this needs to, so it would be, I need to highlight this part and pull, and then pull it
Yeah,
down.
so what I do, go there and keep hitting backspace to get rid of, stop, yeah, and then, okay. And then print C. And then copy and paste. And then resolve. There you go.
Awesome. So it was the production constraint was binding with up here. I didn't pull it down
Yeah,
correctly.
there's some product was wrong
Okay.
in it.
All right, thank you.
Mm-hmm.
Thank you. I'm close, but I don't have it.
Okay. Anybody else not have number 5? Okay. And if you're done with number 6 and you're good, you can keep going. Okay. The production cost is actually 3 for this one, not 2. And inventory cost is always 2.
Okay, so I need to switch the 2s.
Mhm.
Is this one 3 then?
Yeah, well check back here to make sure.
Okay.
Yeah, so per unit cost of inventory holding is 2.
Okay, so that's right. So I just need to switch this to 3 and that's a 2.
Yeah. You doing all right, Ethan?
Yeah, I rewatched the lectures.
Okay. 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 You picked out what you're going to wear for graduation?
No, I haven't.
Yeah.
Oh, do I need to run solver again? Don't I?
Yeah, yeah.
No?
Let's see. Inventory 1,000. 2. Okay. This is one way I sometimes debug. I'll put in the right answer here. 600, 400, 0, 300, 500, 100. And then sometimes if it violates a constraint, that tells you where it went wrong. Okay, something's wrong here. Oh, you don't have your, okay. See over here you had, okay, over here you had ones and negative ones under the inventory for good one, right?
Mm-hmm.
But it's still under here under good one, but you're talking about good two now.
Oh,
So these need to be zeros and this needs to be moved over there.
So the ones need to move over here.
The ones and negative ones.
Okay, and then take that off.
And make those zeros, yep. And you see how I found that because I saw under the optimal formula, this wasn't, the constraint wasn't equal.
Okay, so I start with ones at March, and then go, or negative ones at March and go across, and then ones under that.
Yeah, so you can just sew like this whole block looks right. So I'm gonna bring it under here. Well, those be zeros because we don't want X1. Now see how it works?
Oh, yeah.
There you go.
Okay, thank you.
Mm-hmm.
Did you get 11,800 for number 7?
Yeah.
Okay, cool.
I hope you're right on this, Ethan. This,
Oh.
everybody here is depending on this.
No.
This is what Ethan got for number 6. Is that what y'all got? Don't be scared of challenging Ethan. He may look perfect, but he isn't. He's a human just like y'all. Just a better human, but still a human. So did y'all get that, or? Lance?